Welcome to Part 2. Sagan attended the University of Chicago, which was one of the few colleges he applied to that would consider admitting a 16-year-old, despite his excellent high school grades. Its chancellor, Robert Hutchins, structured the school as an ideal meritocracy, with no age requirement. The school also employed a number of the nation's leading scientists, including Enrico Fermi and Edward Teller, along with operating the famous Yerkes Observatory. During his time as an honors program undergraduate, Sagan worked in the laboratory of the geneticist H. J. Muller and wrote a thesis on the origins of life with physical chemist Harold Urey. Sagan joined the Ryerson Astronomical Society, received a BA degree in laughingly self-proclaimed nothing with general and special honors in 1954, and a BS degree in physics in 1955. He went on to earn a MS degree in physics in 1956, before earning a PhD degree in 1960 with his thesis Physical Studies of Planets submitted to the Department of Astronomy and Astrophysics. He used the summer months of his graduate studies to work with his dissertation director, planetary scientist Gerard Kuiper, as well as physicist George Gamow and chemist Melvin Calvin. The title of Sagan's dissertation reflects his shared interests with Kuiper, who throughout the 1950s had been president of the International Astronomical Union's Commission on Physical Studies of Planets and Satellites. In 1958, the two worked on the classified clarification needed military Project A119, the secret Air Force plan to detonate a nuclear warhead on the Moon. Sagan had a top-secret clearance at the U.S. Air Force and a secret clearance with NASA. While working on his doctoral dissertation, Sagan revealed U.S. government classified clarification needed titles of two Project A119 papers when he applied for a University of California at Berkeley scholarship in 1959. The leak was not publicly revealed until 1999, when it was published in the journal Nature. A follow-up letter to the journal by project leader Leonard Riefel confirmed Sagan's security leak. From 1960 to 1962 Sagan was a Miller Fellow at the University of California, Berkeley. Meanwhile, he published an article in 1961 in the journal Science on the atmosphere of Venus, while also working with NASA's Mariner 2 team, and served as a planetary sciences consultant to the RAND Corporation. After the publication of Sagan's science article, in 1961 Harvard University astronomers Fred Whipple and Donald Menzel offered Sagan the opportunity to give a colloquium at Harvard and subsequently offered him a lecturer position at the institution. Sagan instead asked to be made an assistant professor, and eventually Whipple and Menzel were able to convince Harvard to offer Sagan the assistant professor position he requested. Sagan lectured, performed research, and advised graduate students at the institution from 1963 until 1968, as well as working at the Smithsonian Astrophysical Observatory, also located in Cambridge, Massachusetts. In 1968, Sagan was denied tenure at Harvard. He later indicated that the decision was very much unexpected. The tenure denial has been blamed on several factors, including that he focused his interests too broadly across a number of areas, while the norm in academia is to become a renowned expert in a narrow specialty, and perhaps because of his well-publicized scientific advocacy, which some scientists perceived as borrowing the ideas of others for little more than self-promotion. An advisor from his years as an undergraduate student, Harold Urey, wrote a letter to the tenure committee recommending strongly against tenure for Sagan. Long before the ill-fated tenure process, Cornell University astronomer Thomas Gold had courted Sagan to move to Ithaca, New York, and join the faculty at Cornell. Following the denial of tenure from Harvard, Sagan accepted Gold's offer and remained a faculty member at Cornell for nearly 30 years until his death in 1996. Unlike Harvard, the smaller and more laid-back astronomy department at Cornell welcomed Sagan's growing celebrity status. Following 2 years as an associate professor, Sagan became a full professor at Cornell in 1970 and directed the Laboratory for Planetary Studies there. From 1972 to 1981, he was associate director of the Center for Radiophysics and Space Research, CRSR, at Cornell. In 1976, he became the David Duncan Professor of Astronomy and Space Sciences, a position he held for the remainder of his life. Sagan was associated with the U.S. space program from its inception. From the 1950s onward, he worked as an advisor to NASA, where one of his duties included briefing the Apollo astronauts before their flights to the Moon. Sagan contributed to many of the robotic spacecraft missions that explored the solar system, arranging experiments on many of the expeditions. Sagan assembled the first physical message that was sent into space, a gold-plated plaque, attached to the space probe Pioneer 10, launched in 1972. Pioneer 11, also carrying another copy of the plaque, was launched the following year. He continued to refine his designs. The most elaborate message he helped to develop and assemble was the Voyager Golden Record, which was sent out with the Voyager space probes in 1977. Sagan often challenged the decisions to fund the Space Shuttle and the International Space Station at the expense of further robotic missions. Former student David Morrison describes Sagan as an idea person and a master of intuitive physical arguments and back-of-the-envelope calculations, and Gerard Kuiper said that some persons work best in specializing on a major program in the laboratory, others are best in liaison between sciences. Dr. Sagan belongs in the latter group. Sagan's contributions were central to the discovery of the high surface temperatures of the planet Venus. In the early 1960s, no one knew for certain the basic conditions of Venus' surface, and Sagan listed the possibilities in a report later depicted for popularization in a Time Life book, Planets. His own view was that Venus was dry and very hot as opposed to the balmy paradise others had imagined. He had investigated radio waves from Venus and concluded that there was a surface temperature of 500 degrees Celsius, 900 degrees Fahrenheit. As a visiting scientist to NASA's Jet Propulsion Laboratory, he contributed to the first Mariner missions to Venus, working on the design and management of the project. Mariner 2 confirmed his conclusions on the surface conditions of Venus in 1962. Sagan was among clarification needed the first to hypothesize that Saturn's moon Titan might possess oceans of liquid compounds on its surface and that Jupiter's moon Europa might possess subsurface oceans of water. This would make Europa potentially habitable. Europa's subsurface ocean of water was later indirectly confirmed by the spacecraft Galileo. The mystery of Titan's reddish haze was also solved with Sagan's help. The reddish haze was revealed to be due to complex organic molecules constantly raining down onto Titan's surface. Sagan further contributed insights regarding the atmospheres of Venus and Jupiter, as well as seasonal changes on Mars. He also perceived global warming as a growing, man-made danger and likened it to the natural development of Venus into a hot, life-hostile planet through a kind of runaway greenhouse effect. Sagan and his Cornell colleague Edwin Ernest Salpeter speculated about life in Jupiter's clouds, given the planet's dense atmospheric composition rich in organic molecules. He studied the observed color variations on Mars' surface and concluded that they were not seasonal or vegetational changes as most believed clarification needed but shifts in surface dust caused by windstorms. Sagan is also known for his research on the possibilities of extraterrestrial life, including experimental demonstration of the production of amino acids from basic chemicals by radiation. He is also the 1994 recipient of the Public Welfare Medal, the highest award of the National Academy of Sciences for distinguished contributions in the application of science to the public welfare. He was denied membership in the Academy, reportedly because his media activities made him unpopular with many other scientists. As of 2017, Sagan is the most cited SETI scientist and one of the most cited planetary scientists. Sagan's ability to convey his ideas allowed many people to understand the cosmos better, simultaneously emphasizing the value and worthiness of the human race, and the relative insignificance of the Earth in comparison to the universe. He delivered the 1977 series of Royal Institution Christmas lectures in London. Sagan was a proponent of the search for extraterrestrial life. He urged the scientific community to listen with radio telescopes for signals from potential intelligent extraterrestrial life forms. Sagan was so persuasive that by 1982 he was able to get a petition advocating SETI published in the journal Science, signed by 70 scientists, including 7 Nobel Prize winners. This signaled a tremendous increase in the respectability of a then controversial field. Sagan also helped Frank Drake write the Arecibo message, a radio message beamed into space from the Arecibo radio telescope on November 16, 1974, aimed at informing potential extraterrestrials about Earth. Sagan was Chief Technology Officer of the professional planetary research journal Icarus for 12 years. He co-founded the Planetary Society and was a member of the SETI Institute Board of Trustees. Sagan served as chairman of the Division for Planetary Science of the American Astronomical Society, as president of the Planetology section of the American Geophysical Union, and as chairman of the Astronomy section of the American Association for the Advancement of Science, AAAS. At the height of the Cold War, Sagan became involved in nuclear disarmament efforts by promoting hypotheses on the effects of nuclear war, when Paul Crutzen's Twilight at Noon concept suggested that a substantial nuclear exchange could trigger a nuclear twilight and upset the delicate balance of life on Earth by cooling the surface. In 1983 he was one of 5 authors the S in the follow-up TAPS model, as the research article came to be known, which contained the first use of the term nuclear winter, which his colleague Richard P. Turco had coined. In 1984 he co-authored the book The Cold and the Dark, The World After Nuclear War, and in 1990 the book A Path Where No Man Thought, Nuclear Winter and the End of the Arms Race, which explains the nuclear winter hypothesis and advocates nuclear disarmament. Sagan received a great deal of skepticism and disdain for the use of media to disseminate a very uncertain hypothesis. A personal correspondence with nuclear physicist Edward Teller around 1983 began amicably, with Teller expressing support for continued research to ascertain the credibility of the winter hypothesis. However, Sagan and Teller's correspondence would ultimately result in Teller writing, "A propagandist is one who uses incomplete information to produce maximum persuasion. I can compliment you on being, indeed, an excellent propagandist, remembering that a propagandist is the better the less he appears to be one." Biographers of Sagan would also comment that from a scientific viewpoint, nuclear winter was a low point for Sagan, although, politically speaking, it popularized his image amongst the public. The adult Sagan remained a fan of science fiction, although disliking stories that were not realistic, such as ignoring the inverse square law, or, he said, did not include thoughtful pursuit of alternative futures. He wrote books to popularize science, such as Cosmos, which reflected and expanded upon some of the themes of a personal voyage and became the best-selling science book ever published in English, The Dragons of Eden, Speculations on the Evolution of Human Intelligence, which won a Pulitzer Prize, and Broca's Brain, Reflections on the Romance of Science. Sagan also wrote the best-selling science fiction novel Contact in 1985, based on a film treatment he wrote with his wife, Anne Druyan, in 1979, but he did not live to see the book's 1997 motion picture adaptation, which starred Jodie Foster and won the 1998 Hugo Award for Best Dramatic Presentation. Sagan wrote a sequel to Cosmos, Pale Blue Dot, A Vision of the Human Future in Space, which was selected as a notable book of 1995 by the New York Times. He appeared on PBS's Charlie Rose program in January 1995. Sagan also wrote the introduction for Stephen Hawking's bestseller A Brief History of Time. Sagan was also known for his popularization of science, his efforts to increase scientific understanding among the general public, and his positions in favor of scientific skepticism and against pseudoscience, such as his debunking of the Betty and Barney Hill abduction. To mark the 10th anniversary of Sagan's death, David Morrison, a former student of Sagan, recalled Sagan's immense contributions to planetary research, the public understanding of science, and the skeptical movement in Skeptical Inquirer. Following Saddam Hussein's threats to light Kuwait's oil wells on fire in response to any physical challenge to Iraqi control of the oil assets, Sagan, together with his TAPS colleagues and Paul Crutzen, warned in January 1991 in the Baltimore Sun and Wilmington Morning Star newspapers that if the fires were left to burn over a period of several months, enough smoke from the 600 or so 1991 Kuwaiti oil fires might get so high as to disrupt agriculture in much of South Asia. And that this possibility should affect the war plans. These claims were also the subject of a televised debate between Sagan and physicist Fred Singer on January 22, aired on the ABC News program Nightline. In the televised debate, Sagan argued that the effects of the smoke would be similar to the effects of a nuclear winter, with Singer arguing to the contrary. After the debate, the fires burned for many months before extinguishing efforts were complete. The results of the smoke did not produce continental-sized cooling. Sagan later conceded in the demon-haunted world that the prediction did not turn out to be correct. It was pitch black at noon and temperatures dropped 4-6 degrees C over the Persian Gulf, but not much smoke reached stratospheric altitudes and Asia was spared. In his later years, Sagan advocated the creation of an organized search for asteroids/near-Earth objects, NEOs, that might impact the Earth, but to forestall or postpone developing the technological methods that would be needed to defend against them. 68 He argued that all of the numerous methods proposed to alter the orbit of an asteroid, including the employment of nuclear detonations, created a deflection dilemma. If the ability to deflect an asteroid away from the Earth exists, then one would also have the ability to divert a non-threatening object towards Earth, creating an immensely destructive weapon. In a 1994 paper he co-authored, he ridiculed a 3-day-long near-Earth object interception workshop held by Los Alamos National Laboratory, LANL, in 1993 that did not, even in passing, state that such interception and deflection technologies could have these ancillary dangers. Sagan remained hopeful that the natural neo-impact threat and the intrinsically double-edged essence of the methods to prevent these threats would serve as a new and potent motivation to maturing international relations. Later acknowledging that, with sufficient international oversight, in the future a work-our-way-up approach to implementing nuclear explosive deflection methods could be fielded, and when sufficient knowledge was gained, to use them to aid in mining asteroids. His interest in the use of nuclear detonations in space grew out of his work in 1958 for the Armor Research Foundation's Project A119, concerning the possibility of detonating a nuclear device on the lunar surface. Sagan was a critic of Plato, having said of the ancient Greek philosopher, science and mathematics were to be removed from the hands of the merchants and the artisans. This tendency found its most effective advocate in a follower of Pythagoras named Plato. He, Plato, believed that ideas were far more real than the natural world. He advised the astronomers not to waste their time observing the stars and planets. It was better, he believed, just to think about them. Plato expressed hostility to observation and experiment. He taught contempt for the real world and disdain for the practical application of scientific knowledge. Plato's followers succeeded in extinguishing the light of science and experiment that had been kindled by Democritus and the other Ionians. Thank you for listening to part 2. Please show your support to the channel by hitting the subscribe button. Thank you.